Today we'll start with the new chapter of chemistry in standard 9th, that is water. Chapter number 3, water. Now, we very well know that water is something very important for us in life, because you can see that even the earth's surface, 70% of the earth's surface is water. Our body contains 70% water. So water is going to be there in each and every place and in our body and also on the surface of the earth. And we can also say that the life exists on earth because of the presence of water too. So we know next to air, water is one of the most common substance on the earth's surface. Next to air, of course, air is the first thing. And then the next thing, what is the most abundantly available thing on Earth's surface is water. W. Austin stated that almost all the chemical processes which occur in nature takes place among solutions in water. Water is thus the elixir of life. So we can see that each and every process taking place on the surface of the earth, whether we start with the main producer, photosynthesis, it requires water. If we see about the production of any enzyme in our body, it requires water. We require water even for some of the chemical reactions. The reactions and the chemicals are going to take place only in the solution state, that is when it is an aqueous solution. So water is the most important thing of life. So elixir of life is what Austin stated it as. Water which is found in the natural state is called as natural water, while water which has received from some form of treatment is known as treated water. So yeah, from the natural form, if we are getting water like from the rainfall or melting of the ice from the snow-capped mountains, glaciers, or water vapor condensing, so all these are the natural forms of water. And if we are getting the water as a source of some kind of a chemical reaction taking place, like if I have some kind of a reaction in which hydrogen and oxygen combine to give you water, then that is called as a treated water. Or if I got that acid plus base give you salt plus water, then the water which is produced during the process of neutralization will be the treated water. So that's why we say natural water and treated water as two different kinds of water. For the importance of water, water is important for natural processes and is vital for the growth of plants and animal life. So yes, it is important, very important for the growth of the animals and plants. The human body needs water for almost every function carried out by each and every cell. See, in each and every cell, there will be certain amount of water required for each and every function the cell is doing. So human body requires water throughout. The blood contains around 90% water. The plasma of the blood contains water. So you can understand that each and every part, the complete body requires water in abundance. So industrial processes depend on water are the agriculture, transportation and power generation plants, both hydro and thermal electricity. So not only human body requiring it, even industrial processes require water. We know very well that industrial processes such as agriculture, of course without water agriculture cannot take place. Transportation, because sea transport, the marine transport what we see is due water, so transportation requires water. And then there would be power generation, the dams where pani gir raha hai or turbine rotates, so generation of the power, that is again by water required. Not only that, thermal power plant, what they do is that they heat water and can produce steam, and the steam is then pressuring the turbine to rotate, and hence it is going to be a form of again water. So everything, the generation of power also requires water, whether it is a generation is done by thermal power plant or a hydroelectric power plant, even nuclear power plant will require water for the same. Now let's understand what is the occurrence of water. So in free state, it will be solid state in the form of ice, snow or frost. Yeah. In liquid state on the earth's surface as river water, lake water, sea water and spring water. Below the earth's surface in well water and moisture accumulation in the soil. Above the earth's crust as dew. So you can see the water in the is, and of course the gaseous vapor and there's water vapor, clouds, mist or fog. So you can see the water is available in the atmosphere, or we can see on the surface of the earth in all the three forms. Water is going to be there in all the three forms. We take the first form of in solids. Yes, there are so many ice-capped mountains, snow-capped mountains, frost. All these require all these are solid forms of water. In case of liquid form, the water is available not only on the surface of the earth but also under the surface of the earth and above the surface of the earth. And when we talk about the under the surface, means on the surface of the earth, it will be in the form of river water, sea water, lake water, spring water. All those things are the examples of the earth's surface. Below the earth, you will be having the wells, the underground bore wells and the underground water, that is moisture accumulated in the soil. And above the earth's crust will be in the form of dewdrops. So that is how they are going to be there in the form of liquid, and in the form of gases it will be there in the form of clouds, mist, fog, etc. So water vapor will be there in the air itself, so that's in the gaseous form. That is in the free state, means water in the form of water. Yes. Now apart from that, water will also be present in the combined form. It will be in the combined form, means it's a part and parcel of that particular compound. So in this case, earth's surface covers approximately 75% of the earth's surface. Water covers 75% of the earth's surface, and we see water occurs in the combined form in all living matter, whether it is plant or animal. Plant or animal, both of them will have water as a constituent of their body. That's why it is combined form. It is going to be having water. Like blood is a combined form of water. Accordingly, you know that we have got a good amount of blood in our body, or the tissue fluid also contains water. So the whole body is containing so much amount of water. Water is present in hydrated salts like MgCl2.6H2O and certain minerals. So in certain kind of salts, they have got a water of crystallization. They are the molecules of water which are the fixed number of molecules of water which is helping that particular salt to form into a crystal. So that's why these are called the water of crystallization. So that particular water of crystallization is going to be a part and parcel of the compound itself. So that's why we see that water is an integral part of the hydrated salts. Apart from that, we know that Earth's surface contains approximately 75% of Earth's surface is water. Human body, 70% of the body weight is water. And food products, green vegetables, we have about 80 to 90%, milk contains 80 to 85%, and dry cereals contain 3 to 5% of water in them. So water is going to be there in each and every kind of article, whether it's on Earth's surface or human body, living bodies, or it could be food products. Now we see the thing which we have been learning since ages. So that is the water cycle. So a very simple thing that nature maintains the water cycle by circulating the water from the earth's surface by evaporation to the atmosphere and back to the earth's surface as rainwater. So we very well know, it's a very common thing, that the sea water or the river water is going to evaporate due to the sun rays, and the evaporated water is going to go up in the air. It form into clouds, and the clouds are going to become heavy. They precipitate down as rainfall or snowfall, or that way. So in this way, the cycle of water is going to keep on moving throughout the year, and hence the amount of water, that is the we can say the amount of water is being maintained on the earth's surface by this water cycle. Now we study about water, whether we consider water as a compound or an element. So Yeah, in olden days they used to consider that water was one of the element. They considered it that water was not made up of two particles, not H2O. It was just water, and it was something which is available as a natural ingredient. But now we know that no, it is a combination of two atoms of hydrogen and one atom of oxygen to give you water. So Henry Cavendish synthesized water from its elements, that is two volumes of hydrogen and one volume of oxygen, by igniting the elements in their respective ratio, thereby leading to the conclusion that water is not an element but a compound of hydrogen and oxygen combined in the ratio of 2:1. Antonio Lavoisier further confirmed that water is a compound of two elements, hydrogen and oxygen, and not a molecule of water and that a molecule of water is comprised of two atoms of hydrogen and one atom of oxygen. So two great scientists, one is Henry Cavendish and other Antonio Lavoisier. These two scientists confirmed that it is formed by two atoms of hydrogen and one atom of oxygen, and hence we know that water is not an element but it is a compound of hydrogen and oxygen. Now we see also that how property wise water is a compound and not an element, because we know that compounds have a specific kind of the properties which if we find in water, then we can say yes, water is a compound. But if we don't find it in water, then we can say no, it is not a compound but it's an element. So let's see what are the comparison or how we are concluding that water is a compound. The first thing is, compound is a fixed composition of elements combined in a fixed proportion by weight. And yes, water is in water the elements hydrogen and oxygen are combined in a fixed ratio by weight. So that's why we see that there is composition wise, it confirms that it's not an element, a compound, because it is made up of a fixed amount of hydrogen and fixed amount of oxygen by weight. Compounds have new properties and the original components lose their individual properties. Now this is again very, very important. Compounds always have a tendency that when a compound is being formed, the compound has got the properties which are completely independent of the constituent elements of the compound. So if I say that hydrogen plus oxygen is going to give me water, here hydrogen and oxygen has got properties which are completely different than water. So water has got the properties which are completely different from hydrogen and oxygen. Hence we say that it is a compound. So properties of water differ from the properties of its individual elements, hydrogen and oxygen. Very simple, hydrogen, oxygen, both gases, water liquid. Secondly, hydrogen is explosive in nature, oxygen is supporting combustion, whereas water extinguishes fire. So accordingly you see that the properties of water are completely different from the constituent elements. Third part is, components of the compound can be separated by chemical means only and not by physical means. So it is not possible to remove I cannot separate hydrogen and oxygen from water very easily. I need to use some chemical methods, only then I can separate them. By simple physical methods, I cannot separate hydrogen and oxygen from water. That's why we consider that water is a compound. So the components of hydrogen and oxygen can be separated by chemical means, that is electrolysis, but not by physical means. So this is how we prove that water is a compound and not a mixture or an element. The next we see is the different kinds of water. The first one is natural and treated water. So I discussed earlier also, natural water is those which is we are going to get it from the natural sources, whereas treated is the one when we are getting it from some chemical reaction. So we have first one, natural water is water found in the natural state, is known as natural water. For example, rainwater, spring water, well water, river water, lake and sea water. So all those water which are present in the water bodies, the naturally occurring water bodies, they are the one which are called as the natural water. Whereas treated water is the water which has been received from some form of treatment. When you do a particular kind of a chemical reaction or some treatment and the resultant gives you some water, that is called as a treated water. So the first one is distilled water. It is the purest form of water used for qualitative analysis. It is prepared by condensing water vapor or steam, and it is a soft water free from all solutes. So first kind of a treated water is distilled water. Now distilled water you are going to get when you are going to condense pure steam, or we can say we are going to condense water vapor. So when water vapor is condensed, the pure form of water what you get, which is free from any salts or impurities, is called as the distilled water. So that's why it's the purest form of which is used for qualitative analysis. So in chemical laboratories they use for analysis, they use this kind of distilled water. They are soft water, so and they are free from any solutes. They are free from any kind of impurities in them. The next is pipe-borne water. That is, it is prepared from filtration followed by chemical treatment of water. It is free from bacteria but may contain essential mineral solutes. So when the pipe-borne water is the one which we are getting for our normal supply. So that is a pipe-borne is free from bacteria, means they see to it that the bacteria are being killed from that particular water, but the salts which are essential for our well-being, they are going to be retained. So for our health, if it is required to have certain mineral solutes in them, so they will be present in that particular salt, that is pipe-borne water. And the next one is chlorinated water. That is a treated water, that is water used in swimming pools is chlorinated to kill the germs. So whenever you are going to a swimming pool, you will always find that there will be some particular smell. That smell is of the chlorine. Chlorine has got the property to kill the germs, hence it is a chlorinated water. So chlorine is added to the water so that the germs and the bacteria are killed, so infections are not spread usually in that particular swimming pool. So hence swimming pool contains chlorinated water that to kill the germs. So that was about the different kinds of water and the difference, that is the natural water and the treated water. Okay, so now we move up forward for solutions. So now we come to the next part of the chapter, that is solutions. A solution is a mixture of a solid with water. So when you are dissolving some amount of a solid in water, the resultant mixture of the solute, that is the solid part, and the water is called a solution. So water is called as a universal solvent. See, it is seen that water is able to dissolve a large number of different compounds in it. In fact, most of the inorganic substances get dissolved in the water. Organic substances are difficult to dissolve in water, but all inorganic substances are going to be dissolved. A large amount of substances like the salts, sugars, all of them are going to be dissolved in water. So hence we call water as a universal solvent. Solvent is that particular liquid which dissolves the solid particle. The solid particle is called as a solute and the liquid part is called as a solvent. Okay, so it is this way, that solution is nothing but solute, that could be a solid part, it could be liquid also, not necessary, plus a solvent which is the liquid part. So when the solid part is dissolved in the liquid part, the resultant is a solution. So water has the ability to dissolve a large number of substances, for example salts, sugar, etc. It also dissolves a large number of gases like hydrogen chloride, ammonia, etc. Hence, water dissolves almost every common substance, and this is therefore called a universal solvent. So we can see that since water is able to dissolve a large number of solid particles and a large number of gases also. That's why water is said to be as a universal solvent. So these are the terms which are going to be used for solution, that is terms solvent, solute and solution. So what we have the solvent. Solvent, we take it over here as water. So what is a solvent? The liquid, which is generally water, or medium of dissolution, the medium in which the dissolution takes place, the medium in which you are going to dissolve some particular particles. These are called as the solvent. So solvent is generally water or the medium of dissolution which allows the solute to dissolve in it so as to form a solution is called a solvent. So that particular substance which is allowing the solute to get mixed into it or which allows the solute to get dissolved into it is called as a solvent. To form a solution is called a solvent. The next one could be solute. Now that solute could be any salt like a common salt, sodium chloride. So sodium chloride over here becomes the solute. So if I take this particular example, then I can say that this is water. This is going to be sodium chloride. So sodium chloride over here is the solute and the resultant over here is salt water. That is nothing but salt water solution. So here we see that solute. What is solute? This is over here. Solute is the substance which dissolves or disappears in the solvent to form a solution is called solute. So when you are going to add the solute into the solvent and if that solute disappears, it just dissolves, doesn't appear at all. Like for example, when you are taking salt and putting it in the water, can you see the salt any longer? No. As soon as you put it and stir it, you will find that the water is completely same. It is still transparent. It is still not having any. You cannot see any particles inside. हाँ ये तो एक salt दिख रहा है, ऐसा नहीं हो सकता. You cannot see the salt at all. So the salt has disappeared into the solute in the solvent, or it has got dissolved, disappeared or dissolved in the solvent to form a solution. Hence, this is called as the solute. The solute is the one which substance which dissolves or disappears into the solvent to form a solution. This is called a solute. And finally is the solution, a homogeneous mixture of a solute in a solvent. That is a uniform mixture of two or more substances. Homogeneous. Okay. We have the word over here. Homogeneous. Homogeneous means thoroughly mixed, completely mixed up. There is no place which has got different kind of a property than the other. So when it is uniform mixture, a uniform mixture is of two or more substances. When two or more substances are going to be mixed together and you get a uniform mixture of the same, you call it as a homogeneous mixture. So a homogeneous mixture of a solvent in a solvent whose composition may be gradually changed by changing the relative amount of compound. So I can change a homogeneous mixture, I can change a bit of its composition. Homogeneous mixtures are also like water is a homogeneous mixture of hydrogen and oxygen, but no, it is not a mixture, it's a compound. But here, because it's a fixed ratio, here it is not a fixed ratio, it is in the form that it is mixed up and I can increase or decrease anything. Like I can increase the amount of salt, like I can take a glass of water, put just a pinch of salt, and I can take a spoon of salt. A tablespoon filled with salt and put it inside. I have both the options available and in both the cases it is nothing but salt water. So that's why if I am able to change the proportion in which the solute is added into the solvent, then it is a solution wherein you can have a relatively change or by gradually change or changing the relative amount of the components. So according to the relative amount of component which is present inside the solution can be of two kinds. One is concentrated and other is dilute. The simplest example of this would be Ruh Afza. You know Ruh Afza? Yeah. So Ruh Afza is what? A bottle, a शरबत का bottle. Can you drink it directly? अगर पिया तो भी बहुत गंदा लगे. It will be too sweet, right? So what do you need to do? You add water to it. So basically, the bottle of Ruh Afza, which contains water, sugar, and the rose essence and everything, that is a concentrated solution. Got it? The bottle of Ruh Afza, which is the complete sharbat, which cannot be intaken directly because it is very thick and sweet. Because it has got less amount of water in it, it is called as a concentrate. Whereas what we do later on to drink the sharbat, we take a glass, take only some amount of Ruh Afza in it, and then pour water in it, stir it and drink. So that particular sharbat which you are taking for drinking purpose is a dilute solution. So what do we differ? The differ is very simple, that if the amount of water, that is the solvent present in the solution, is less, it is a concentrated solution. If the amount of water is more, it is a dilute solution. So depending upon what is the quantity of water present in the solution, it will be either concentrated if it is less, or dilute if it is more water. So we have over here, amount of solute is given in a given weight of solvent determines the concentration of solution. Dilute solution, a solution in which the amount of solute is relatively small compared to the amount of solvent in the given mass of it, is called as dilute solution. So we see dilute solution is which? In which the solute content is less and water content is more. Right? Ruh Afza kam, pani jada, dilute solution. Right? That is what they are given. Solution in which amount of solute, that is amount of Ruh Afza, is relatively small. Got it? So the one in which the amount of solute content is less, relatively small, compared to the amount of solute in the given mass, is called as dilute solution. Whereas concentrated solution, a solution in which the amount of solute is relatively large compared to the amount of solvent in it, a given mass of it, is called as concentrated solution. So if the amount of the solute in the solution is large, that is the bottle of Ruh Afza, there amount of water kitna hai? Bahut kam. Okay, so that is the concentrated solution, that is comparatively higher amount of solvent is present in it. We also have the different kinds of solution. So in that, one kind of solution is a true solution. So the solution can also be differentiated as a true solution. A true solution has its own characteristic properties. What is that? Nature wise, it is clear, transparent and homogeneous in water. So you will find a true solution in which you cannot see that, okay, देखा एक glass में है, अंदर salt डाला हुआ है, but yes, you cannot see it. You cannot identify that the water has got salt in it, okay, unless and until you taste it. So it is clear, transparent and homogeneous in nature. So when it is clear, transparent, homogeneous in nature, it's a true solution. What is the size of the particles of the true solution? Particle size is molecular, and the particles can pass through the pores of the filter paper, cannot be seen through under a microscope and do not settle down. So I cannot identify or I cannot filter that particular solution by just taking into the filter paper liya डाल दिया तो okay, salt and water अलग हो गया. No, it is never going to happen. The salt is going to pass through the filter paper. So the filter paper cannot filter the salt water and make out water separate and salt separate. So when it is not possible to filter out the impurity or from the solute, from the solvent, from a solution, in a solution, we say that that particular solution is a true solution. So it cannot be filtered, it cannot be seen under a microscope, neither they settle down. So all these three things is not possible in case of a true solution. Separation can be done only, so solute can be recovered from the solvent by physical and not by chemical means. We know we can do it by physical method. Just evaporation करो, पानी निकल गया, salt रह जाएगा. So that is quite possible. You can do distillation. You can take water also and salt also, separate out. So yes, this is possible to be done only by physical means, not required any chemical method, because there has not been any kind of a chemical reaction between the solute and the solvent. A true solution is therefore a mixture and not a compound. So yes, we feel that it will be a compound in that case. Why? Because it is not getting filtered out. But no, it is not a compound, it's a mixture, because it can be separated out by physical means and does not require any chemical means. So that was about the true solution. So the next kind of solution is saturated and unsaturated solution, which we take up in the next lecture.